So these two are going to be replaced. This one will be replaced. I need to put a new switching regulator there. The other one is broken, so I had to remove it in order to test the rest of it. The fuse over here is broken. And this, I'm not sure if this metal oxide virus is probably not broken, but its body is. So I'm replacing both of them just to be sure. So let's power up the soldering iron here. Takes a little while to get hot though. And I'm going to have the desoldering station for the surface mount stuff. Let's take that out for now. So I have some stuff here. More silica gel, always nice. So here I have some new switching regulators. They do look like they're probably the right ones. Better not mix up the new and old ones. I should put the broken bits in a separate container. Is this from? Oh, yeah, that's the old one. Yeah, I'll just put them up here among the other broken stuff. So I need to clean that up a bit, but I can remove the other components in the meantime. I'm going to add some flux to make it easier to remove. Should not add all that cat here, that will make it harder to remove. Yeah, that's probably it. Kinda hard to remove because there is a big ground plane there. Lift it a little at first and then from the other side. It's lifting the copper foil a bit there, which I don't like. Yeah, that's not very nice. Try to flatten it a little bit. It delaminates from the circuit board and pushes up. That's when it's harder to get at. Oops. Because there is a full bridge rectifier in the way there. I'm trying to push down the foil with the solder tip in hopes that it will lessen the problem of the delamination. Maybe it did a little bit. So I should clean that up a little bit with I'm going to use my Chemtronic solder braid because I like that one more than the no-name ones I have. There's quite a lot of solder on there. Yeah, I think that's better. Going to... Is it broken there? Or is it just... hopefully not. We shall measure... Okay, it's just that it goes up and back down. It's fun now when I have the thermal camera and I can see how long it takes for it to cool down. I guess I could blow on it. Doesn't make a big difference. So let's get... Yeah, we should clean up the other end up there too. Actually, I'm going to cut off that the messed up part here. Going to clean that with some 2-propanol before I solder the new stuff on there because it gets a bit messy. Let's see if we can take that fuse there. I guess the fuse is probably easier to take with the hot air, but I'm going to start by just heating it up a whole bunch with the solder tip. Because there is quite a lot of thermal mass on it. Actually, maybe I can just heat it up enough that it will pop off. Just worrying about that delamination risk. Come on, you get loose. Oh, there we go. No, not my ESD mat. Put it up there for now. Bet this fuse is hot. Yeah, I can use it as a little light here. And then it's the MOT. So nice with the camera. I can look and know like, yeah, I can touch it here without burning myself. And I can touch it here, but not over there. Now it's already a bit preheated. Maybe we'll use the solder sucker here because of the through PTH type connector. What is that? It's like, I forget. TH is through hole. What is P? Is it part through hole? Where is my solder sucker? It has escaped. Someday I will have order here and everything will be so much better. One can dream. Here is a whole box of tools, but no solder sucker. I guess I have an old one, or maybe I'll just use the wick instead. Yeah, this old one doesn't really have any oomph in it. Could probably be fixed. Maybe it's been stored with the spring compressed. No, I would do that. Oh well, we'll use wick then. Let's use the sheep wick. But the sheep wick doesn't really have much in terms of flux, so we'll add some flux. Also, I don't believe it was actually sheep. Oh yeah, that works well. It's too hot to handle. Well, it's I'm not going to keep that component, so we can be rough with it. Can use a small RDR clamp. Oh, come on. They're really stuck in there. Oh yeah, there we go. Nice. I guess this one is also kinda hot. That's actually nice. I bought some porcelain clay because I want to try using my what's it called my I have a dentist oven that you make teeth in, but I'm going to use it for porcelain. And you can't glaze it because it's not hot enough, but I should be able to at least make unglazed porcelain. So I bought some black clay, and one thing that could be nice is like a little component tray to put really hot components on that I could have on my workbench. It looks kind of messy here. Let's clean it up. There should be a syringe of 2-propanol somewhere here. Hopefully I didn't take it down into the basement. Oh, there I see something. No, that's an oil. Oh, there is another one. Oh, yeah, here we go. I put a really small tip on here. Where is the camera even? Where is the focus even? It's far away. So it's a pretty small tip, but 2-propanol is quite volatile and it will creep through small holes easily. So having a really small syringe tip helps. This is not a sharp tip, but because it's so small, it's still a bit of a danger, so you shouldn't be pointing at it. But it makes it easy to just put very little on there. I guess I should find some nice brush to use also. Maybe toothbrush or something. Because I've used Q-tips, like cotton swabs in the past. But the problem with cotton swabs is that you get like a bunch of fibers stuck to your circuit board. Looks good enough. I guess it's hard to see in... There we go. Still out of focus. I need to show it over here somewhere. But enough of that. I guess this is a programming interface here. Here's something else. I don't know how many programming interfaces they need. I mean, how much do you need to debug a freaking waffle iron timer? I got an ST microcontroller. And it's really been able to see what it says. Now I'm curious. 32F0, 30F4 P6 or something. But yeah, it's one of this, like the time. I think it's a Cortex M0, like it's one of their lowest, what do you call it, performance. And how much performance you need for waffle iron timer anyway. I'm not having a good grip here. Don't want to break anything. Let's get some, yeah, let's actually use cotton swabs for now. Because I don't have a better solution. Well, I guess I do have a toothbrush here. Let's try the toothbrush. Yeah, it's looking kinda nice. Maybe I should start brushing my own teeth with 2-propanol. Oh, I'm dripping everywhere. I was thinking that I should keep technical streams to YouTube and game streams to Twitch. I don't really have an audience on my live streams on either platform. And in OBS, as far as I figured out, it's not easy to change. I guess you could have different profiles you could load it with. But there isn't an easy way to just be like, oh, stream to Twitch today and stream to YouTube this other time. So because it was sitting at Twitch, I went with that. It gets pretty cold from the evaporative cooling of the 2-propanol. Still pretty hot over here. Right, so yeah, I guess start populating components. So, oh yeah, I should clean up there first. This solder wick is also really hard to cut. Or maybe that was just because I was cutting a piece that didn't have tin on it. I don't want to breathe this. Come on, I have an exhaust and everything. Big ground plane making it hard here. Well, maybe not ground, but big rail. I mean, I can see the smoke go up there. I guess it's just when I'm close to it, it goes towards me. And it's an interesting, frustrating experience. And the YouTube creator Alpha Phoenix actually did some investigation into this phenomena. And I think it was essentially just that when you have something close to where the smoke comes from, it creates like a, how do I show this on this camera? Well, you should just look it up. Yeah, it looks new and fresh. You don't want to have dirt here because this is the high voltage part of it. So if you have debris or icky stuff there, it may cause voltage creep or even short circuit, which is bad. This IC isn't hard to get the right orientation of. Like, sure, they don't mark out where one is here, but it only has 7 pins. So it only fits well one way. This IC was actually updated, so they changed the power handling. Like, they essentially cut the rating in half. And I think it's just one of those cases where they were optimistic about its capabilities, but then once they put it into the field, they noticed that, okay, they burn up earlier than we thought. So then they had to change that, so they essentially deprecated the old part number, they added -TJ or something to it, and yeah, half the rating, I don't know. Can we be sneaky and use some solder paste to just keep it in place? Or not solder paste, sorry, I mean some flux. I guess it's not sticky enough because it's too warm here. We will need solder. I'm going to use my thin solder. It's so thin I can't even find it. Where are you? There you are. Yeah, let's just cut a piece of this. Looks good enough. I don't have a good way when I test this. I think I have like a 1 ampere uh, automatic fuse I could use. That didn't work out well. But even with a 1 amp fuse, it could happen that it could get the breaker in the wall to trigger. Depends on like how fast the fuse is and how loaded the circuit already is. It would be really nice to have some sort of completely separate power supply for these things, especially one that you could set power limit or current limit on. I can't even pick this thing up because it's so thin. Let's see if I can get it to go where I want it this time. Like I only got it on top of the leg and not like on the pad. Because I guess the pad wasn't hot enough. Seriously? Come on, pad, get hot. There we go. I'm going to just add a bit more on all these just in case. Like if you can't add to the opposite side, then it's not hot enough. I guess we'll clean it as the last last operation here. Oh, I'm losing my components. All the way over there. Okay, so that's the new fuse, new big capacitor, new small capacitor, new metal oxide varistor. Let's start with the big capacitors that I've already lost. There they are. Oh, what? Which direction was plus and minus? Good thing I have 2 of these boards. But I do have photos, so even if I wouldn't have had 2 boards, could have figured it out. Yeah, I think I want to put down a blob there using the thick wire. And then while it's still hot, put it down there. You don't need that much though. Like it doesn't need to be a thick blob. Something like that, perhaps. Going to reheat these parts, make sure it properly flows in there. Looks like it might do the trick. I guess we'll put a small capacitor on there. Oh, I need to open a window. It smells like cancer in here. And the cat is in the $1,000 share, of course. I hope these capacitors will do. I couldn't figure out the rating of the old one, other than it was 100 microfarad, but I didn't know if it was what voltage it is. But because the secondary side works well with 3.3 volts, so I suspect that's that's the wrong way. So I suspect that's what it's set to. So then I think this one was rated for like 5-6 volts or something like that. But then I also had to find one that had the physical shape so that it would fit here. I sure hope that works. Oh, it's pretty hot. I don't like to cook these. I mean, they do. I do think you can solder them in an oven, so that means they can be heated up to a high temperature and cool down again. But they can't be like used at a high temperature. I also opted for. I tried to get as high temperature rating as possible for these also because again it's in a waffle iron, it gets hot. Let's see, fuse. So much empty bags. Here we go, fuse. A bag in a bag in a bag. Bags all the way. Couldn't find the exact same fuse, it seemed unusually small, like usually they're longer. Maybe directives regarding how long they should be in relation to voltage has changed over time. But I did find this one. It's a bit smaller in the width, but probably works well. It's also a bit anonymous. I don't even know what's up or down on this thing. I don't think it has an up and a down. I sure hope it won't tombstone. Actually, let's put some solder down and then place it while it's hot. Oops, daisy. I want it to sit on there straight and nice, so it looks nice. don't move. Making a mess. Let's try to just heat it up evenly. Not my proudest solder, but I mean, by definition, everyone except one would be. So now it's just metal oxide varistor left. We need 2 of those. Very blue, very nice. I sure hope they don't go boom. I tried to match the rating as close as I could. Did it live here? Does I guess it's on this side. Boink. I like the little artery clamps. I guess we could give it a little bit more so it really creeps into the hole there. I guess I need to sharpen this side cutter. So yeah, we need to clean it up a little bit. I guess we can't clean it with a dirty Q-tip. I was close to buying an ultrasonic cleaner, but then there is a bunch of components that don't really like going through an ultrasonic cleaner. Oh, I really don't like how loose this one is here. That's just because the copper foil here is loose. Maybe we can put some cyan acrylate in there. Might be a good idea. Is this one hot? It looks much hotter than it is. Or it's just a weird emissive... No, it's just very hot. I guess it depends. I haven't made... like I do get gain data from my thermal camera, so I could make an absolute scale but now it just automatically changes scale. So when I have my hands under here, we can see that this thing is roughly body temperature. That's why I don't burn when I touch it. But now it looks real hot because everything else is, I guess, much colder. I was cleaning. Oops, do not break the NTC. Get those pesky fibers everywhere. I guess we could power it up with 3.3 volts just to see that it works. It would at least show if there is something terribly wrong with that component. Is this thing already hooked up? It is. I think that this is ground. This is... Does it look right? Yeah, it looks right. So let's start the software. Waveforms. Supplies 3.3. Oops, 3.3 volts. On. It keeps resetting. What? What's going on? It's never done this before. Is it just poor connection here? What on earth? That's so weird. It's maybe that capacitor isn't very good. We got an overcurrent condition there. I think that this one was the one that seemed the least damaged. I mean, obviously the microcontroller runs. Could it be that one of the transistors that drive the display pad? No, but I did test this. I tested it without this switching regulator. But now I have the new one on. Because this board, which has the fried metal oxide resistor here and the bulgy capacitors, I think this one works out of the box. No? Now they both behave the exact same way? That can't be a coincidence. Could it be that my USB bus is too loaded or something? I mean, I am running several cameras on the same bus. Yeah, let's hook it up to the laptop instead. Hello, laptop. I have a job for you. Oops. Wave farms. Where do we put laptop? Over here, perhaps? Back there? Supplies. 3.3. Yeah, I guess it was the USB bus. It's so bright, it's hard to see. Let's. It's so dark, it's hard to see. Yeah, let's set it a bit lower. One waffle. Two waffles. Okay, let's try that aboard. I don't see what I'm doing. I don't see what I'm doing. Seems to be working. The big question is, will it just explode when we power it up with line voltage? I think we'll repair the other one before we find out. Save the conclusion for later. I can put the laptop away. Where is power? There is power. So dark in here. Put that away. Right, so we're finished with that board. Let's take the next one. Let's also get rid of this thing. I just wanted to be able to keep track of them. Let's put some flux on there. When I bought these solder sponges from China, there was a problem with the customs, like a mix-up. They thought it was a sea sponge, like this is brass, but they thought it was organic matter. So yeah, that was a bit messy. Finally got it through. Maybe we can try to suck up some solder here directly. See if we can do this better than the other one. I guess the thing with these things is that you need to do it quite a lot of times before you learn what the best way of doing it is, and I clearly haven't done this enough times. Like I don't want to use too much force here. I mean, one method could be to just destructively remove it and then just remove the pins afterwards. If you can destructively remove it without causing damage to the board, that is. But you might be able to do that simply by squeezing the capacitor. Like maybe you can get it to detach from its base. Or not, maybe just make a mess. Ugh, it smells terrible. Come on, you, loosen up. I guess maybe I should have two soldering irons. Could take one on each side. Ah, it's too warm. Okay, I think we got it lifted there. Maybe even without lifting the foil, the trace. This is not the right tool for this. Come on, grab it. This capacitor is not being very nice. Oh, there we go. Such a relief when it suddenly gets loose. Look at all this heat here. There we go. Still delaminated a little bit. That reminds me, I should remember to glue the other board. Yeah, I don't like this solder braid at all. I do like this one. And no, I'm not affiliated with Chemtronics, I just like this product. Let's see if we can get the other one loose. See how much heat we need to pump in. Yeah, I think the trick is probably to have one of those solder irons that can heat both ends at the same time. Come on, you were just loose. What happened? Yeah, better, but still a little bit delaminated. Nice. Guess we might as well get rid of that switching regulator. I think I maybe want to reposition the board before I get rid of the small capacitor. Though I'm not even sure there is a problem with the small one, but I figured since both the big ones were damaged, that might as well replace the small ones. Not enough heat on this end. Yeah, it's hot there now. Maybe I can just heat the sides alternatingly until it gets loose. Come on. Oh, there we go. And the other side. It's easier with the smaller ones, not as much thermal mass. Maybe I spoke too soon. I guess I already cleaned that off. Or well, the first phase of cleaning. Let's get rid of that fuse. Let's try the same thing. Heat sides alternatingly. So much icky smoke. There we go. The one thing I don't like about electronics is how freaking disgusting everything is, and it feels like everything is super toxic and bad for you. Ugh. And metal oxide varistor. Let's not crush any small components here. Let's maybe put it this end in here. I don't think there were any components there. I guess I just solder sucked this one. No, sorry, I mean I wicked it because I didn't find the sucker. Use the artery clamp. Oops, daisy. Come on, heat, go down there into the hole. Very good. Let's tidy it up a little bit. I'm getting a bit hungry. But it would be nice to kind of conclude this repair. Also, it wasn't really long since I ate. Maybe it's all the toxic fumes that makes me hungry. Oh yeah, and I forgot to make coffee. I might have to... Well, I guess I shouldn't be drinking coffee while I'm also messing with this stuff. That's like asking for trouble. Sure, it's not leaded solder anymore, but there are plenty of other unhealthy chemicals in this. Except for this syringe, this I could drink. Well, actually these two propanols seems to be contaminated because it smells terrible. I haven't cleaned off the excess solder there. Ah, looking good. Trying not thermal shock it too much, but I also want to be done today. It's icky there between those two pads, which is like the worst place to have a conduction. Yeah, now it's looking better. Alright, we can start putting components back, I believe. So yeah, guess we'll start with that one. But this is a very awkward position to do that in. Is this better? It seems awkward too. Ah, wrong button. I almost said wrong lever. Yeah, I think this is probably better. Because now I can... Yeah, I don't know. They're all bad options. One switching regulator. I actually bought one extra of every component. Because you never know if you make a mistake or something. But hopefully I'll end up with a few random components that will take up some space here and never get used. Yeah, let's just fasten it there to begin with. Is that good? We'll have to do. Maybe that's a bit much. But I guess better too much than too little. I burned my finger, it's hot. Did I get it? It's good. Will it work? Will it catastrophically fail? Maybe I should improve those a little bit. We will see. Small capacitor. Ow. I think it's actually easier to start from the other end, but now we have started here. It's a much bigger plane here, bigger thermal sink. I want to move it a little bit more back. Maybe something like that, but yeah, I was hoping it would also stay. Oh, this is embarrassing. More flux. If in doubt, more flux. Oh, it's very hot. Hopefully I haven't cooked it. Well, maybe. And then we have the big capacitors. I want to move it a little bit more to the right. Maybe like that. Yeah, they didn't get that hot. Always like That's kind of funny when you do a thing a few times, always the last time, that's when you're the best at it. And that's also when you stop doing it, because then you're done. Why don't they have an up and a down? I mean, it doesn't matter, but bugs me. Oh yeah, I should put some solder down there first. Yeah, that's kind of nice. Then the metal oxide varistor. Want to have the text this direction. Buttons have an interesting thermal look there. Yeah, let's use some extra flux, why not? I guess it cools very quickly when you cut it. Now when there is air in here, when you push here quick, like faster than it can go out that small hole, you really feel the bounciness of the air, the compressibility. Making a mess. Yes, fuel-soaked paper near the hot equipment. That's always good. Just might work. Let's test it with low voltage first. And then we'll test the other one, so we can let this one dry a little bit before we put the high voltage into it. Oh yeah, I got rid of the laptop and stuff for now. I guess I'll have to go get it. I should really make sure that my USB hubs and stuff have extra power locally, because I have pretty long cables for them. So it would be good to have some local power there, just so, because my computer is far away from my desk. I hope this just works, so I can make coffee, work a little bit on my template processing system and stuff. Maybe play some Minecraft. Not too much though. It's such a time thief. Oh no! Ah, that was a remote control to the light. Let's see, I believe this was plus, this was minus. Oh, it remembers. I wonder if it stores the time to the flash or something. Alright, nice. Now we just need to devise some sort of somewhat, possibly slightly safe solution to power this up on the lab bench to test it. So first we notice that it uses these, I don't know what you call them, like shoe, no, flat pad something, so I don't know. But you can see it right there. That's where it uses those connectors. And I do have those. It's, I mean, sure, you could use crocodile clamps, but you don't really want loose, flimsy crocodile clamps when you're having live voltages. Especially if you also have pets, and you have, like, you never know when a pet might startle you or suddenly jump up somewhere. Then if you have flimsy connectors, then it's much greater risk that things go bad. Ah, wrong button. That's the right button to get light in this other room where you can't see me. But here I might have an automatic circuit breaker rated 1 amp, because I did see that not too long ago. And I was thinking this could come in handy. I should make sure I know where it is. That's usually how I make things disappear. I sure hope this doesn't add like an hour to my stream, me just mumbling, looking for things. Oh, here we go. No, that was just something that had the same form factor as Deutsche Industrie Normalisierung. I don't know. DIN. It's it's like a method for how you connect these circuit breakers and stuff. They go on a little rail, sort of. That we usually refer to as a DIN rail from the DIN from the standard set. nice. That tool is nice. It's I found a tool for when you use expanding nuts that you put inside walls. But that's not what I need right now. Now I need a fuse. What's that? Is that fuses? I found fuses. Fuses. But these fuses, 1 amp, 4 amps. Let's use the 1 amp one. But now it would be real nice if these were in a nice little contained box that I could have on the desk here with some safe connectors. But if, I don't know, like this is also somewhat exposed here. Like this thing isn't really safe until it's stuck onto this rail I talked about, and also with things to the sides. But yeah, we'll do the best of what we got. We could also use a different safety measure. We could have like a water boiler connected in series with this, so if there is a bad short, it will not trigger the fuse, it will just boil the water. I've done that a few times in the past, and I should probably have some sort of adapter already for that. I wonder where that may be. I don't even remember how it looked. I really need to get my lab in order. Like this project, I'm just helping someone in the village with their waffle iron. But yeah, if I had things in order, it would be so much easier. Then I could have like, here are my line voltage lab stuff, and here's my low voltage lab stuff. Got some nice cable here we could use. Yeah, I think I found. I was probably using this abomination. Because here we could connect a water boiler here and connect it in series with this one here and connect this one. It would be nice if this was like an integrated unit with the type of screw terminals that are considered safe, that you can't accidentally touch. But okay, we do have this stuff here. I mean, if this thing was stuck here so it wouldn't easily fall, just that would improve safety a great deal. Let's remove this vise for a moment here. So we'll use this. Connect the water boiler here. Let's go get the water boiler ready. Just going to wash my hands before I touch stuff that I actually use for food. I should really I say make because I was thinking of a contained solution, but I should really just get a water boiler for this particular purpose. I do have some heating elements, submersion heaters. The only thing is that it needs to have water in it when you use it, otherwise it just breaks. Oh nice, my dishwasher is finished. I've been getting a bit behind, been having some back pain, so I haven't really been doing my dishes, which have led to a mountain of dishes in need to be done. I need to clean my water boiler. It usually stands too close to the frying pan, so it gets splatter on it. Right, so here we have a water boiler. That's a start. Yeah, of course I connected in the one that we can't see. And what's next? We want the fuse in series as well. Or do we? When we have the water boiler, I guess we don't really need a fuse. Yeah, let's skip the fuse for now. Because right now it feels more like a safety liability than a safety feature. Oh, this screwdriver needs some TLC. Yeah, that might work. Yeah, it would be really nice with some thing where you could just set, like, I guess a current trigger profile. Some things have inrush current, so you don't want it to trigger for that, but you could set like some margins and then have a foot switch, like power it on. And then if something goes wrong, it powers off immediately. With a nice emergency stop button. I need a cable for power. Here we have a lot of cables. Though none of them seem to be right. So many cables. Never the right one. I think I should have some cables that already have a connector in one end, which would be the best cable to find for this purpose. And I also like when they do have a switch on them, so you can. But I could just connect a power strip with a switch. That's a nice extension cord. I don't want to break a nice cord. There are lab cables, Bluetooth speaker, serial ATA cables. They shouldn't be there. There's a lot of cables here that shouldn't be here. And that's the cables that I'm going to recycle. Oh, so many connectors. I need to really go through and throw out, get some space, do some inventory management. Ah, this is frustrating. I should have a cable. What's this? Antenna cable. That's completely deprecated. I found some cables and switches that I've thrown out. Let's use that. Recycle. It's so funny, whenever I decide like, let's get rid of this crap, then I get back to it because I figure out I need it. A real ugly connector. And a kinda scary push button that I don't know when it's on or off. This looks kinda ancient, but they usually put a lot of effort in making ancient stuff good. So when is it on or when is it off? Okay, so it only cuts that one side. Pretty standard. So let's take some lamp cable. That's not lamp cable. That one is kind of short, so that one can sit between this contraption. I want to have a bit of a longer one that I can actually connect to the power. I guess I do have power up there. Yeah, let's use this one here. Now where did I put my... there it is. My trusted side cutters. I lost one of my side cutters by forgetting it inside of a neighbor's lamp before I moved from Gothenburg. But these things happen. Some future person will be like, what the heck is this? Why is it in here? Always nice to leave some surprises for the future. assembly out of the switch while you're connecting it. And then put it back. Oh, stupid phone! Why did the music become super loud after someone called? Important to not get any of these little strands that miss the hole. This cable is like thin enough as it is. It's a 0.75 square millimeter cable in cross-sectional area. And that's, well, I mean, if we pull it full load, that's a bit little, I guess. I'll write to my friend. Twitch. I don't like how they had connected this before, where they put brown to blue and blue to brown. Like, it doesn't really matter, but I do like it the when it's the right. If I should be real pedantic about this, I should put the blue one in the non-breaking connection, so that neutral is always connected and that you break the phase or line. But since with our connectors you could just like take it out, put it in the other way, so you would never know which one is which, so therefore it does not matter. Right, we got this thingamajig here. I'm not sure I'll get a good, like, what do you call it, relief? Cable relief? But it will be good enough for this purpose. Actually, it's pretty good. Nice. I may not be very good at keeping this thing into the camera, but it's not very interesting anyway. Might work. But yeah, the one thing I don't like about this switch is that you don't know which position it's in without testing it. So let's redo the ends here, they're not very nice. So we'll put, let's see, how do we do this? If we put it here, then we get phase goes in here through the water bottle, then it comes out here. That's a good start. Seems good enough. Then the other end needs a connector. Yeah, this connector is kinda sketchy. In many ways. Can you even open this thing? Oh, it opens. This is one of these weird foldable ones. A bit rusty, but we'll have to do. This grounding cable here, it's a bit short. Like you want the ground to be the last one to lose if you just manage to somehow pull out the entire thing. Yeah, let's get rid of this entire thing. Screw the ground one in so it doesn't come loose. Maybe a little bit more so we can make sure we reach both ends. Could be good to do. That will have to do. What? Why is it hard to fold it? Yeah, this cable is so small, so we have to be ugly and put this one the other way around. Otherwise it won't even make contact with it. Yeah, this one is a bit tensed. It's not the best solution, but it will have to do for now. It's just for this one experiment. Alright, so now we just need to hook up the actual DUT, or device under test, as we might call it. I thought this thing only had a blue wire in it. I couldn't find the brown one, but it was in here. So we'll hook this one up here. And this one here. So have we been thinking correctly? So the power comes from this cable, it goes all the way down there through the switch, then it comes up here, and then it goes in here through the water boiler, comes out, goes to device under test, comes back, and then back into the wall. Disappears somewhere to a power plant in distance. Let's see if I have, yeah, there we go. Urgh. Ow, ow, ow. Cramp in my foot because I was standing on a thin little thingamajig. Here we go. This cable is the smallest one, so it's red. So we'll grab these. Hopefully they are the correct size. They do seem to fit. Now we need the thing, the top, we call it the crimp tool. Networking crimp tool. Networking crimp tool. Where is the yeah, I don't know what those connectors are called. I should stop trying to refer to them. Or just call everything thingamajig from now on. That's also a viable solution. Oh, it may be in that I had a bunch of tools in a box. Oh, that's a different crimp tool. Oh, where is that crimp tool? It should be somewhere in the vicinity of those ends, cable ends. Maybe I was using it in the basement. I really don't want to go down there. I guess I'll do it if I have to. Just hoping that all the tools I would need would just be here. Because that would have been quite convenient. Guess it would have been a bit too convenient. I'll have a quick look out here. Maybe it's here. I'll never learn which of my two lamps goes to which button. Here's another networking crimp tool. Yeah, I'll probably cut out the range of my wireless headphone. It works while I'm in the basement, but not while I'm getting there. Alright, it better be here, and I better find it right away, because I don't want to spend my time looking for a tool that I need to use for 5 seconds. It's so dirty down here, I need to clean. blind, what do you call it? Blind rivet tool. Whole box of hammers. Ah, there we go. This is kind of the low version tool. My sys have a much nicer one with the ratchet and everything, but this will have to do. I've sometimes pushed too hard with these and just like broke the end thing. But always test them out a bit after. And also I'm not just going to leave this thing on the table, I'm going to put it in a vise so that it's secure. And before I power it up, I would like to know the state of that switch. So we can do that by simply disconnecting the water heater, and then when we measure there, we'll see if there is power or not. But now we need the vise. When it comes to safety, making sure everything is that one was oily. Making sure that things are secure. I think that's like one of the most important things. I mean, obviously all electrical considerations, but if things are not secure, then everything else sort of fails as a consequence. This one is secure. It can't like pivot so that these aluminum things short circuit something. It's far away from all the electrical points here. We can actually operate this thing. I mean, if we go over here, it will hurt. But as long as we're over here, it won't hurt. So that will be the goal. But obviously when it comes to safety stuff, you always have, I mean, you're ultimately responsible for what you do and you need to know what you're doing. Another thing that's a problem is if you have to like lean over a bunch of live things to connect stuff, that's typically not good, which is a little bit the case right here. Okay, we have live voltage here now. So if the connector is on, this thing here should show 230 when we measure across the connector here. It was off. So now it's off. Good. And I always like to put these on because if components explode, it's pretty nice to not get things in your eyes. So now we just connect the water heater, turn the water heater off, connect it, turn the water heater on, and now we turn the device on. It seemed it worked a little bit, very shortly, briefly there. What happened? That's weird. We don't have a short, so that's good. But what happened? I mean, it did work briefly. Oh, do you see that it's very hot there? Is that... Oh, that capacitor. Did I connect it the wrong way? Minus? How the hell did I connect it the wrong way? Oh, I'm stupid. Well, I did order extra. I have one extra. Hopefully that first one saved the other one. I bet that fuse also broke. Yeah, I feel stupid. I mean, I made a mistake that kind of broke the thing. This other capacitor could potentially be charged. No, I don't think so, actually, because of how hot this other one is. Alright, let's test the board that we didn't screw up. The cable is disconnected. I hate these connectors. I feel like it's so hard to remove them without causing damage. Man, that's so stupid. It's always something. Like, I thought I was taking good care that I connected these things the right way. But apparently not. Alright, it's connected. We have it in the thermal view. I don't know the state of this connector, so we'll figure that one out. Connect live power. On. Off. Good. Off. Connect this thing. Turn water boiler on. Let's hope this one is not terribly broken. It shows the display. Nothing seems to be heating up. Let's turn off the light here, which I don't really recommend because if you don't see what you're doing, it's not good. Oh, it's not too dark, I do see. I can turn on a little light over here. So let's try if it works. Was it this button here? Something is heating up under that button. What's under that button? It's a capacitor! Why is that one heating up? This one is not connected wrong, is it? Okay, turn off, disconnect. Let's turn it around so we can see the other side of it. There is no reason for the capacitor to get hot now. I mean, if it does, that would explain why both capacitors were broken. Like if the design of this board is such that these capacitors are under a terrible load, no matter how you do this. Connect power. Turn on water boiler. Turn on power. It has power. Let's start the beeping thing. Was it that button? Yep. I used the toothpick just to have some... like this thing will sit beside some membranes that will protect it. So we do see that the switching regulator gets hot, which makes sense. The inductor there gets hot, and the path between the inductor and and the regulator. Capacitors don't seem to get hot. Maybe I was seeing something else, or was just being fooled by something. It could be that something else here got hot and leads the temperature over there. Why is the toothpick so hot? Yeah, that inductor is heating up. But it's, yeah, of course you're taking down 230 volts to 3.3 volts. I'm tempted to just leave it like this for a while, but I don't like having it like this because cat and stuff. So I'm not going to do that, but I do think that the temperature has stabilized there. I don't think it's getting hotter. Also haven't implemented the thing with my thermal camera so I get absolute readings. I guess I could connect it to the app and look there. Yeah, I think it has stabilized. I wonder, is this capacitor getting a bit hot? It could be that the heat from the switching regulator is kind of like traversing. I mean, of course it is. It will be traversing these thick copper traces and get into other components. So maybe it wasn't cooked by the waffle iron itself, but just cooked from being a bit inefficient. But yeah, I think I'm not going to stream fixing the other board. I'll replace that one capacitor, hope for the best. It was stupid of me. I always do that one stupid mistake. That's why, you know, if you're supposed to repair 2 boards, you should get 3 boards to repair. But yeah, I guess that wouldn't have worked. But let's safely power off. Like that. And yeah, thanks for watching. It was fun. Like it was kind of fun to work with the thermal camera. Fun to try to get the setup where I have both a regular camera and a thermal camera. So that's always fun. But yeah, I would like better ways to get the cameras in there, like better holders for it, and a better testing jig for live voltage stuff. But yeah, anyway, have a good evening or day or whatever.